Hello, everybody. It is great to be here one more time. And my name is Gary Fowler. I'm a serial entrepreneur and investor. I've done 17 companies. I've been involved in 2 unicorns. I was on the original management team of Click Software, which was sold to Salesforce for $1.35 billion, and also Eva.ai, an AI HR tech company that I co-founded with Dr. David Yang. Love artificial intelligence and quantum computing. I've written 163, maybe 164 articles, actually, in the last 18 months. A lot, because our world's changing, as we know. There's more data around us. As there's about 49 zettabytes of data on the planet today. If you took CDs or DVDs, that would go 35 times between the Earth and the Moon. And that number increases about 67% every year. So we are in a state of infobesity. With that, I'd like to introduce my guest, Davide Venturelli. David's a double PhD. So you want to know something about quantum computing and quantum, what's happening? He's the guy. He is truly a rocket scientist. He works at the NASA Ames Research Center. He's been a senior scientist, visiting research scientist, National Space Aeronautics and Space Administration today, a senior research scientist. Has all kinds of insights in terms of AI and quantum. So he's a person to ask, and I'm proud to have him as part of the show today. Hey, how are you today?
Hey, good to see you. Hello,
Nice
everyone.
to see you. So I like this, a double PhD. What the heck made you decide to get 2 PhDs?
Well,
Did you wake up one morning and say, listen, I want to go into a restaurant and I want them to say doctor, doctor, and mean it?
no, it's a little less impressive than what it looks on paper because there's a large overlap between my 2 PhDs. Is actually the fact that I initiated a PhD thesis in 2 institutions that were initially coordinated, but then it felt that it was too difficult between Italy and France to coordinate. So I had the 2 advisors, 2 different things, and then I ended up getting essentially a degree in 2 institutions in 2 slightly different domains. One is computational physics, so simulations of the condensed matter, and one is nanotechnology and theoretical nanotechnology specifically. So those were essentially related projects that ended up giving me a double degree. It's true. It's not the thing I advertise as much as double doctor, but it's nice to have 2 diplomas.
I think you got the twins too, because you have 2 master's degree, correct?
Well, yes, but in Europe it's a little bit different because there's a system for which you have the bachelor, then you need to do the master, right? So I'm not a hoarder of titles, okay? I mean, it just because I lived a double life between Italy and France during my education, so I ended up having a lot of double degrees because of that, which meant I had to defend twice the exams. So
did you have to write did you use the same paper in both, or did you have to rewrite your thesis when you were doing
there were like 2 publication differences between I had like 6 publications in total, and 2 were in one defense and 1 not in the other. But yes, the core was similar.
Wow, that's amazing. So how did you go? So you went to University of Bologna, and you studied international political science. And why did you do that?
Gary, you're digging up information about me, which are actually pretty rare to find.
Well, unless you have LinkedIn.
That's true, but the University of Bologna is kind of an exploration I did. I'm a physicist by focus, but yes, I did spend 2 years at the University of Bologna studying political science as well.
Well, I mean, it's like you go from being a rocket scientist to political science. What did you wake up one day and say, listen, I'm interested in maybe becoming a diplomat, or how did you do that? I mean, it's just interesting.
I mean, as I mentioned, like my education was physics, computer science, but during my PhD, I realized that maybe I was a little bit too technically focused. And it was the period of the Arab Spring. There were like a lot of things going on in the Middle East, and I did not understand them. And I was frustrated that my focus in education was based on understanding science and not at all about history. And I felt very ignorant. So I started studying on my own. And then I realized, I said, wait a second, I'm following essentially syllabus as a self-discipline of universities. So in Europe, universities are free, right? So I passed the test. I studied for the test to be admitted to the master's degree. And I started studying that during my last years of PhD. So that's the story.
That's amazing.
But you find information in some sense that are not typically my CV. Okay, they are on LinkedIn, but they're not.
Yeah, I mean, this is public stuff. It's not like I had to dig that far. Okay, so you've gone down through that. Have you done anything with it? Did you take any diplomatic positions or working with the UN or anything, or you just said?
Well,
no?
If I become a very famous person, this interview will be a source of information for books on me. But yes, I actually ended up applying to become a policeman, a scientific police. I mean, I always been attracted to work for the public thing, like for the public sector. Now, I was in Italy back then. This was before I moved to America. And so one of my attractions, I mean, of course, I want to do things in science, right? And so I decided that maybe an entry point for being part of government operations was scientific police, CSI, essentially. So I ended up applying, but I didn't go through the entire procedure because I moved to America actually shortly afterwards to attend Singularity University and learn about entrepreneurship. So that plan really, was more a fun thing. But yeah, I
mean, it sounds like you like I don't know what kind of hobbies you have, but are they that different? Do you like on one side you say, oh, I like to ice skate, and then I like to do bungee jumping?
This webcast is going in directions I did not forecast. Yeah,
that's okay. The first 15 minutes I get to know you, so it's interesting. So you went to you were a professor at Carnegie Mellon, and you're still doing that, correct?
Yeah, this is a rather recent appointment to teach a specific class on quantum optimization and machine learning. And this is in a strong collaboration with two professors of Carnegie Mellon, which are part of the faculty, of their permanent faculty, one in electrical engineering, Elias Stowe, and one in Tepper's School of Business, Sridhar Tayur. So that course is a very interesting course because it tries to meet the demands of the private sector to hire quantum experts. You don't need to know, quantum field theory or the basic reasons of why the equations of motions of quantum observables are the way they are, but they need to have a solid understanding on applied use of quantum devices for use cases in machine learning and optimization. And we try in a semester to give them that ability to use, understand quantum computers, not be fooled by things and so on. And so it's a very unique course.
Okay, so what's really happening right now? Are quantum computers being used today in a commercial sector? What kind of places are utilizing though? I know you're working with NASA, but are companies using those today, and where are they using those? The ones we can talk about.
Yeah, so I work for USRA, which is University Space Research Association, is a non-profit institution which was created under the advice of NASA and the National Academy of Science in 1969, when the rocks from the moon arrived. And the universities wanted to study them, but they belonged to NASA. And NASA did not have a way to interface academia with the agency. So they created this institution which employs me. So I live in a limbo between contracts with the government well, not in a limbo, it's actually a very hybridized way, contract with the government, working for NASA under a task order of NASA, and also interacting with academic collaborators and also other agencies such as DARPA and so on. Now, I do not interact that much with the private sector, despite being in communication due to my experience and standing. But my primary expertise in quantum is related to research, but applied research. So what's going on is that the U.S. government has invested as a first mover, in my opinion, several billions of dollars through the National Science Foundation, through the Department of Energy, through DARPA, through IARPA, through multiple foundational agencies that decided to foster an ecosystem, which is now pretty lively. There are like 5 centers sponsored by DOE, which are funded at $25 million a year. There are 5 centers sponsored by NSF, which are funded at $5 million a year. But usually there are also interbreeding with big tech. So there is IBM, Microsoft, Intel, Google that is supporting those initiatives as well. And the United States have really taken the lead in trying to organize the effort as a system. So there's 2 websites. There's quantum.gov and AI.gov, which are very nice nerdy logos for the coordination directly from the White House of the activities on quantum information sciences. And I see that the rest of the world is following a little bit the example. I see Germany and France made a similar attempt to fund initiatives. So this is what happens from the public sector. And then the private sector is very interested, but of course, they're de-risking their investment by actually typically bandwagoning what's happening from a funding perspective from the government. Mm-hmm. And I think it's the right way to do it because we are very early stage in terms of impact. So the companies that can actually afford to decide to take a long-term view and have like a team that understands what's going on, typically are collaborating with some research projects which are either sponsored by a government agency or by a university one way or another. And then everyone is trying to detect the first signatures of what we call quantum advantage. And quantum advantage is a bit of a undefined concept, but in some sense, it's the moment where you, as a business leader, will decide that it's better to use a quantum computer than anything else to perform a certain computational task. And that's a high bar.
So where can we use the quantum? Where do you think quantum computers can be utilized, and where can't they be utilized from your standpoint?
Yeah. So the low risk answer to this is simulations of quantum systems. Like, quantum mechanics is the theory that underlies everything. Everything is quantum mechanical. This coffee cup is quantum mechanical. So in theory, it's a very useful tool. It's a mathematical framework that is exponentially difficult to simulate. So if you want to actually understand a chemical reaction, for example, it would take tens of days on a supercomputer to actually figure out the details. Now, it turns out that if you have a quantum computer, you would program the quantum computer to emulate, to actually represent the quantum mechanical system itself, and then the self-simulation would be very fast because you're performing the experiment in a quantum way. So there's an exponential speedup expected in chemistry, material science, drug pharmacology, potentially, but the requirements for this are so high in terms of control of the hardware, which we are more than a decade away to really reap the benefits of such an idea, which is though pretty an established target. Like everybody knows you can use a quantum computer to simulate quantum mechanics efficiently. Okay, now that's a little bit one kind of long-term motivation. But in the meantime, before even we get there, there are targets which are optimization and machine learning, so logistics, data science, all these sort of things, which could be attacked. But there is no mathematical guarantee that we are better than neural networks on TPUs or the genetic algorithms on clusters. So we're trying to see whether the benefits that quantum mechanics provides us can be tweaked to allow us to find the better solutions, or to train a neural network faster, or to have a learning power which is larger. And right now there's a lot of empirical science on this. Like, people are experimenting. Like, where you take a hardware that has 50 qubits, you try and see, without having a mathematical guarantee, whether the probability of success of solving a problem is faster than what you could do with an alternative method. And then,
Well, how do we know if we don't know? I mean, how do you know if something's faster unless you try it, right?
Well, I mean, sometimes you can prove on pen and paper, like the number of operations you need are much less. So you would know even before trying. But you make a good point. In industry, that's almost never the case, that you use the mathematically proven algorithm, the elegant things that you teach at university. At the end of the day, when it really comes to a cybersecurity operation, there are some black magic of things that work. You are not sure why, but they've been optimized over the years, and they work. And so I agree with you. For a real business impact, for a real quantum advantage, at the end of the day, you will need an empirical estimate of how you're doing. So yes,
Ron, you need to show results too. I mean, I hear what you're saying. So we don't know today if the quantum computer could be better than a supercomputer in certain types of applications, right?
Well, in some in the application that do not concern quantum mechanics. So if you take out simulation of quantum systems, so chemistry, pharma, material science, that thing, then yes, I should say, we know that for very large problems, very large and very powerful computers, so we're talking like, billions of qubits, and problems that requires many days to solve, if not even months or years, then we do have some mathematical proof that even in machine learning, even in optimization, we can get some advantage. However,
but is it that big of an advantage? Because I heard, one of the reports said that a Google's quantum computer could be 100 million times faster than a supercomputer, which means it would take 10,000 years, takes 200 seconds. I mean, that was their quote.
Yeah, no, that is true, but that is on a specific problem which was designed to show the separation. So that problem is some sort of a self-simulation problem, and it's a quantum mechanical problem. So again, it's more in the domain of simulation. It's not in the domain of machine learning or optimization, which are industrial applications that are more speculative. But at the same time, what I want to say, what you can prove mathematically is that yes, eventually you will get an advantage for sure. But probably it would not be worth it to go through all this like worldwide attempt if that's the only advantage you can get. So in reality, we all think there's much more, and that much more is probably not provable mathematically.
Yeah,
like, you need to see it in practice, and this is not really a hope of a few business leaders say maybe it works or not. It's like the top scientists of the world, they really say at the end of the day, we can't prove everything ab initio. Deep learning itself, it works in practice. It enabled industries and so on. but you can't prove how much it takes to train a neural network. How many?
Well, it's like a cell phone. It works, but tell me how it works exactly, where the signal is. I'm curious. You know what I mean? It's like some things, it just rings. I can't tell you where the signal is. I can tell you a little bit about why it rings, but that's sounds like it's there. with quantum. So what do you think in terms of how much interest is there in quantum right now on a 1 to 10 scale? What do you think?
Well, I think I've seen a report of the other day that says that the venture capital investments in quantum this year, up to date, they are equivalent to to all the investment in the 3 years prior. So you can see that, you know, we're in a parabolic interest line, and there's a lot of consolidation going on with the companies trying to go public through SPACs and so on. And there's some software startups that will be probably acquired one way or another. But
you were saying there's some problem with them trying to do SPACs?
Say it again?
You said that some of them are trying to do SPACs?
Well, I mean, for a fact, there are a couple of companies that have announced the fact that they're going public through a SPAC. And there's been mergers already announced. So things are shaking and moving, even among the early players. So those companies that started 2012, 13, I mean, quantum computing has more than 30 years of history, but as an industry, it really started in the early 2010s, because that's when the world understood if they really focus on system integrating qubits, they can actually make a processor. It was not known before, in some sense, that it was possible.
What is a qubit? Tell the audience about what is a qubit.
A qubit is
a position. Why are those terms important?
Yeah, no, I mean, a qubit is the minimal thing you can think of if you want to do quantum information processing. So the same way as bit is the minimal amount of information you can define in classical computer science. So instead of being, if you have a thing that can be in two states, 0, 1, you can create a computer around it.
Yeah, because you have some stability. At least you know where it's going to be, right?
Yeah, in quantum, the minimal thing is a thing that can be in 0, 1. But the fact that at the microscale, we know that the state is never defined as simply as one bit of information. Is actually defined by a vector in a exponentially large space. And so even a single qubit is an object that can be essentially represented as 3 real numbers, as a matter of fact. So it's not like 0, 1, but it's actually 3 real numbers. It's the minimal amount of information, amount of variables you need to describe its state. And so, and then if you have 2 qubits, the minimal amount that you need is actually 4 complex numbers.
Really?
So you have an exponential increase of the requirements to represent mathematically the state of registers of qubits. And we believe that we could exploit this, certainly for memory advantage, because it grows exponentially, but
right.
also for computational advantages. So that all the algorithms we create are trying to steer the operations in this exponentially large space that we cannot simulate via digital computers.
So what do you think is in terms of adoption? What do you think? When is it going to start coming out to the mainstream? It's kind of like the computer industry.
We have already.
Can you do quantum as a service? Can you get into quantum, and is it okay to do that or not? Do we have that?
Yeah, I mean, look, so right now, quantum as a service is a service that software or hardware startup provide as a platform to prospective end users. Every end user today, and there are some companies in finance or in pharma or in chemistry or automotive that are committed to explore use cases. Okay,
that's great. What about What about what's happening in China with quantum computers and AI?
I know quite little. I mean, I know what's publicly displayed. China boasted a large investment of $10 billion in quantum technologies. Um, my impression is that there's not clarity how this 10 billion really exists. I mean, it might be a building that costs
Yeah,
10
yeah,
billion. Okay, so I don't know. But what I can tell you, the science that comes out of China, and there's like a big professor that everybody know that is in every paper, is top notch. Okay, so
yeah.
they are certainly up to speed on a lot of things. Okay, they have a large firepower in terms of skilled labor, and I think that even if in quantum computing specifically, they're probably not at the forefront. I think the United States has a lead. In
Yeah, as long as we
communication,
don't screw it up. I mean, we got to keep moving forward. I mean, sometimes we get so locked into things we don't move forward. I mean, now's a critical time for everybody on the planet. There's too many things happening that need to be analyzed entirely different ways. And, so quantum computers coming online. What do you think the danger? Do you think there's a danger with quantum computers and AI? In fact, I had a panel this morning. We talked about what kind of nefarious things could happen if you have unsupervised AI in quantum computers. I mean, Elon Musk paints a very bleak picture. I don't necessarily believe that, but at the same time, it's something we got to think about, right?
yeah, I don't have the presumption to have the same wisdom of Elon Musk and other seasoned entrepreneurs, but I can say that I believe in human ingenuity and in our ability to deal with problems as they come. And I
Mm-hmm.
think that having too much caution is not great. As a matter of fact, I believe that one of the risks we face is that we end up maybe destroying potential very useful collaborations that could result in solutions to climate change or things like that, because we are afraid of I don't know, like export control of ideas.
Yeah. I mean,
While
that's
at
how
the end of
that's
the day, we're all trying to this is not a trend. This is not an applied technology. This is actually a thing which is fundamental in physics, quantum information science. So it's a quest for humanity. It's not really a weapon that we need to develop before the others, right? This is my approach. Of course, I follow the laws and compliances of the United States of America. So,
you no, that's fine. I understand that. So, what do you think? We're coming up to the top of the hour. What are your closing thoughts, and what do you think? I mean, what's going to happen over the next, let's 5 years from your standpoint in terms of quantum and AI, and how do people reach out to you?
well, people can reach out to me by googling or on LinkedIn. As I have a lot of information you told me out there,
Yeah, you
so
got a lot.
you can say that I'm a very approachable person. But yeah, no, I mean, my thought. I think I'll just follow up to what I just said in some sense. Like this is a little bit like space exploration. Okay, it's the thing that we need to do as humanity, as opposed to an applied technology. We want to know what can be done when you couple the most important concepts in physics with the most important concept in computer science. And there's nothing more fundamental than that we discovered as a species.
Right.
In terms of advancing our power to elaborate information. And so we need to do it. It's a mandate which comes from our innate curiosity. So I believe that the future of quantum cannot have really a winter. It could have a winter in funding because of political or, I don't know, worldwide reason. Maybe tomorrow everything will be about biotech. I don't know. In terms of funding, I don't know. But definitely the
We call it
intellectual revolution will not be damped.
Yeah, no, I agree with you.
And
I agree with you. And part of it is taking the course and moving forward. I can tell you one thing, that we have these incredible technologies out there. We better use them for the right things. My next week on Friday, I'm speaking at the United Nations one more time, about technology as a tool for peace, because there's a lot of nefarious ways we can use quantum, but we got to figure out how we can work together. We have a very small planet. It's not that large. We poisoned it in a lot of ways with pollution and dirty oceans and climate change, etc. So I'm real bullish. I don't know about you, but about quantum computers and AI to help us solve some very serious problems we got in front of us, which I'm sure we can get over, but we need some extraordinary brain power to be able to do it. And I think quantum and having the vehicle of a quantum computer and our unsupervised or semi-supervised AI that can really help. We talk about it as an intelligent assistant, like a guardian angel that will be with you all the time. Probably what it's going to be, because we'll have two classes of society: the people that understand the data and the people that don't have any clue about it, right? So our job is to democratize that opportunity, just like we're doing here today, and bring it out to the world. So, and did you mention what's the best way to get? So LinkedIn is the best way to get a hold of you?
Sure. It's a very good one. Yeah.
No, that's great.
There is also a newsletter that I cover. You can find it on my website, on my group website. And every month I list the research papers that are coming out on applied quantum computers. So you can go on US Array, so reax.usarray.edu/quantum, and there is a newsletter button there. So that's another way to get in touch with me.
That sounds great. Well, I want to thank you for taking time out of your busy schedule to join me today for GSD Presents Silicon Valley AI and Tech. I really appreciate it. Thanks for your incredible insights. To the audience, my name's Gary Fowler. It is great to have you here one more time, and stay tuned for next week. I will have Koshala Ventures on. We'll be talking about their investments in areas like IoT, AI companies, and quantum computers. So stay safe, stay healthy, and I'll see you soon. Bye-bye, everybody.